Hello, today we are covering 8.4, simplify, multiply, and divide rational expressions. So we are first going to start by just simplifying these. This first one is actually very easy because it is already factored for us. To simplify, you can just cancel out like terms or like expressions. So the x minus 3, that is in both the numerator and denominator, you can cancel, and your simplified form is actually just x plus 1 over x minus 2. And that's it. Because x plus 1 and x minus 2 are different expressions, they can't simplify any further. Question 2 gets a little more difficult because we are actually going to have to factor these. So you can either do a difference of squares for the first one, or you can think of it as factoring factors of 9 that subtract to 0. That one might be the easier way to think about it actually. You know that negative 3 plus 3 is equal to 0. So x minus 3, x plus 3. And that is the factor of our numerator. We also then must factor our denominator. So we go ahead and find the factors of 6. And these must add to 5. Now, the tricky thing about factors of 6 adding or subtracting to 5 is that actually both of these will get to 5 groupings. Both of these factor groupings can equal 5. Just one would be positive 5 and one would be negative 5. So we really have to pay attention to the signs here. Now, I already squared the ones that are the correct ones because you can take positive 2 times positive 3 and get positive 6. And then 2 plus 3 is equal to 5. So our factor here is x plus 2 times x plus 3. And then we can rewrite these numerator over denominator. Reduce out what you can, and then your solution is what you are left with. The next two we actually are not going to factor, but instead find the greatest common factor, so it's not the same, quite the same, I should say. But we do have a similar idea here. The first one, we can't really take a greatest common factor out. It just is what it is. The second one, we can actually pull out a 3 from each term. So if you were to distribute this 3 back through, we'd get the original. And then you can just reduce these 3's, so you are left with x over x minus 2 as your solution. Pretty simple, I hope. Once again, on number 4, the numerator cannot be reduced, so you just leave it. The denominator, though, we can divide both terms by 4. That is our greatest common factor. The problem with this one is there's nothing we can reduce with these guys, and our expressions here are not the same. So there's actually 2 good answers here. You can either say that this does not simplify, or you can say that just the original is the most simplified form. Both of these are okay answers. Alrighty. Now that's simplifying. To multiply or divide these expressions is not that much different. So we're going to have a pretty easy one here for this next example. You can, if you want, multiply across and then reduce, or you can reduce first. To multiply across, it would just look like this, where you just combine. It's actually more writing than you would need to do. That is not necessary. You're just really just making these one fraction. Okay, so if you can think about it as numerators can reduce any denominator can be reduced by any numerator. Do it that way. So I see an x minus 2 and a numerator and in a denominator, and I see an x plus 1. Doesn't matter that they're in two different fractions, they would still reduce. And then I also see a 5 and a 10. So the 10 just becomes 2 and the 5 goes away. So in the numerator, I'm left with x. And in the denominator, I have 2 times x minus 6 times x minus 1. And that is my simplified form. Now, this next one is not factored, so we need to do our factoring step before we can even try to reduce. So I'm going to find factors of 3 that add to 4. I know that's just 1 and 3. Then I'm going to find for the denominator, we actually already did this one, factors of 6 that add to 5. So there's that one. And then over here, I'm going to find factors of 10 that subtract to negative 3. And then lastly, I'm going to actually just do a greatest common factor here. I'm going to pull out an x from each of these terms. And now I'm just to my reducing step. So I reduce what I can. And I am left with x minus 5 over x. Notice I can't reduce this x because this term over here does not also have x. So I am done. That is my simplest form. Now, I do want to point out that this and this are completely equivalent. If you plugged in an x to this top problem and solved, and you plugged in x to this bottom problem and solved, they would equal the exact same thing. So that's pretty cool. It's just simplified. It didn't really change anything else. To divide, we do this thing called keep, change, flip. I also like to call it, you can't divide by a fraction, but you multiply by the reciprocal. So you are going to keep, if we go this way, the first fraction as is. Change your sign to multiplication and then flip the next fraction. From here, we have, once again, difference of squares, greatest common factors, and normal factoring. So I need to do all of these things. This one is a greatest common factor. I'm going to pull out 2x from each of these. The denominator on the first fraction is a difference of squares. The numerator on the second fraction is a greatest common factor. And the denominator is a normal factoring. So now I can go ahead and reduce whatever I can. So I have x plus 2, x plus 2, x minus 2, x minus 2. I do want to point out we do have another x minus 2, but it's only a 1 for 1. I reduce this one, I reduce this one. I can't also reduce another one. If there was another x minus 2 in the numerator, I could go ahead and do that. Okay, so now I'm as reduced as I can, so I'm just going to multiply across. So 2x times 3 is 6x over x minus 2 times x minus 1. And that is my reduced form. Now you'll notice over here I have restrictions on the variable. This is just when does the denominator equal 0, and those can't be answers. So if we back up a step here, erase this and erase this real quick. We need to solve for when each of these equals 0. And those are our restrictions. If there's a repeated one like this, you don't need to write it twice. All right, so these would be your restrictions on your variable. X cannot equal those things. Even though 2 of them end up getting canceled out, they still can't equal those. All right, that's all. Have a great afternoon.